In one of our previous session, we have gone through top 10 basic SQL interview questions. In this video, we will take it into the next level. So, we will go through top 10 intermediate level SQL interview questions and I will give a detailed explanation of each of the questions and their answers. So, let us move on to our first question. The first question is, what are constraints? Explain different constraints. This is a very commonly asked question because the understanding of constraints will let us maintain the accuracy, reliability, and integrity of our dataset and database. So, this is very commonly asked and it is a very important question during SQL interviews. So, constraints are basically used to specify rules for the data in a table. And this ensures accuracy, reliability, and integrity of the dataset in the table. And following are the constraints which are commonly used in SQL. So, these are the commonly used constraints which we see in our day-to-day activities as a data analyst or a SQL developer or even a Tableau or a Power BI developer can come across these constraints. So the first one is not null constraint. So not null constraint will ensure that the column will not be having any null value. So it ensures that a column cannot have a null value. The second one is unique constraint. Unique constraint ensures that all values in a column are different. So the column cannot contain any duplicate value. All the values in the column will be unique. And also one thing to note here is the column on which unique constraint is specified can have null values. So there is an exception for null value. A column for which unique constraint is specified can have null values, but the values cannot duplicate other than null. So that is unique constraint. So the third constraint is primary key constraint. So a combination of not null and unique constraint. So primary key constraint can be considered as a combination of not null constraint and unique constraint because for primary key column or a column on which primary key constraint is specified, all the values will be unique and also the column should not contain any null value. So it is a combination of unique constraint and not null constraint. And coming down, we have the foreign key constraint. So foreign key constraint prevent actions that would destroy link between tables. So normally we use foreign key constraint to establish relationship between fact tables and dimension tables. So in that case, whenever a record in the dimension table is deleted or get affected, the same thing will get reflected in the fact table. So in order to establish that kind of a relationship, we use foreign key constraint. And the next constraint is check constraint. Check constraint ensures that value in a column satisfies a specific condition. So if I come down, I have noted an example here. So we can see that here there is a column called as age and the data type is integer data type. And I have specified one check constraint here, that is age should be greater than 18. So whenever a person is entering data or inserting record into the persons table, there is a condition that is age of that particular person should be greater than 18. And whenever that condition is not satisfied, the record will not be accepted and we will get an error message. So that is the purpose of check constraint. And coming down, we have a default constraint. So sets a default value for a column if no value is specified. So as the description suggests, default constraint will specify a default value for a column if there are no values specified. And in the example here, we can see that we have a column called as city. The data type is variable character, and whenever a person is not entering any value into the city column or city record, the value will be New York. So this will be the default value for the city column. And below we have a create index constraint, and it is used to create and retrieve data from the database very quickly. So the purpose of index is to actually improve the performance of our database or the queries which we are running on a particular table or a database. And coming down, we have an example in which I have used almost all the constraints I have explained. So here I am creating a table called as persons table, and we have ID column where I have specified the unique constraint. And one more constraint I have specified here, that is not null. And the last name constraint, I have specified another constraint called as, sorry, the last name column, I have specified another constraint called as not null. Coming down, we have first name, age, city and spouse. Age I have explained when I went through the check constraint, and city we have the default constraint that was also explained. Then coming down, we have the spouse ID, which is the foreign key constraint or the foreign key specified on the table. So here what happens is we have a separate table called as spouse table, and the primary key for that spouse table is ID in that particular table. So we are actually creating a relationship between spouse ID column in the persons table and ID column from the spouse table. So whenever there is a change in record that is happening in the spouse table, the same thing will get reflected in the persons table for the spouse ID column. So we are creating a foreign key relationship between spouse ID and ID column from the spouse table. Now let us move on to our second question. How many primary key and unique key can be there in a table? A table can have only one primary key, but it can have many unique keys. So previously we have gone through primary key constraint and unique key constraint. So the same definition applies here. So what is a primary key? A primary key is a column or a set of columns that uniquely identifies each row in a table. Primary key constraint ensures that the value in the specified columns are unique and not null. That is a combination of unique constraint and not null constraint. And when coming to unique key is a constraint that ensures the value in a column or a set of columns are unique across the entire table. So the value will not be repeating except null. So here that is specified. Unique key can be null unless the columns are also marked as not null. So what happens is here id int not null unique. So what happens is here this will actually act as a primary key. So once we remove this not null, now on this column only unique constraint is specified. That time the column can contain null values also. Otherwise, with the not null constraint specified, the column cannot contain null values. Otherwise, with only unique constraint specified on a column that can contain null values also. That is the difference between primary key and unique key. So once more I will tell. So primary key is a combination of unique key constraint plus not null constraint, and unique key simply tells that a column can only have unique values except for null values. That is, it can also contain null values. So that is the difference between primary key and unique key. Now moving on to third question. What are joins in SQL and type of joins? So joins are used to combine rows from two or more tables based on a related column between them. So it need not be a single column. So it can be multiple columns also. That is, a join condition can be specified on different columns. Here in the definition, it is specified that combine rows from two or more tables based on a related column. So it is not on a, it can be based on multiple columns also. And these are the different kinds of joins in SQL. So there are inner joins, left join, right join, full outer join, cross join, self join, join with exclusion, and non-equi joins. And I have a screenshot for the joins. I will show that. These are the joins that we will come across in SQL. So the first one is a left join. So it will take all the records from table A and common records from table A and table B. So that is a left join. And the second one is an inner join. That is, it take all the records common to both table A and table B. So that is the inner join. And the third one is a right join. It takes all the records from table B and common records from table A and table B. And coming down, we have a left join with exclusion. So what happened here is it will take the records which is only available in table A, and the common records will not be considered. Common records and the records which are only available in table B will not be considered in the output. So that is the left join with exclusion. The next join is full outer join. So in this join, everything is joined between the two tables. That is, every record from table A and every record from table B will be there in the output. And the next one is full outer join with exclusion. So here the common records, actually this is kind of opposite to inner join. So here the records which are common to both the tables will not be there in the output, except that all the records will be there in the output. That is, the records which are only available in table A and the records which are only available in table B will be available in the output. And here also the tricky part is the where condition. That is, here we are specifying A dot key is null or B dot key is null. So this where condition converts the normal join into join with exclusion. And the final join in this diagram is right join with exclusion. So this is kind of opposite to left join with exclusion, where right joining is happening, but the common records between both table A and B is not available in the output. So this is right join with exclusion. Three more joins which I have specified. Those are cross join, self join, and non-equijoins. So in case of non-equijoins, the join condition will be having something other than the equal sign. So it can be greater than, less than, not equal to. So those are joins where the equal to sign will be replaced with some non-equi conditions. So that is non-equi join. And cross join is we are joining every record of a table with every other records of the another table. So that is kind of a Cartesian product. So consider that we have 5 records in table A and we have 10 records in table B. So all the 5 records from table A will be joined with all the 10 records in table B. Happening in self join, we are joining the same table with itself. So self join actually we apply in cases where we are trying to find manager employee hierarchy kind of questions. We use concept like self join. So that is where this join comes into play. Now moving on to next question, which is what is the difference between union and union or? Union is basically used to combine the result set of two or more select statement. So the difference between join and union is that here the appending of data is happening. So we are combining result from different select statement and the number of rows are actually getting increased, or it is kind of appending data happening in the union clause. And now what is the difference between union and union all? In union, duplicate rows are eliminated, but in union all rows are kept. That is, whenever we are doing a union clause, the duplicate records will be eliminated from the record. Let us take this example. So here what I'm trying to do is I'm selecting all the students name from class A and I'm creating a union with all the students name from class B. Now consider that we have same student name repeating in class A and class B. So for union, in the final output, there won't be any duplicate student name. So every student name will be unique. Even if there are duplicate student name, the union clause will handle that, and in our output, we will only have student name which are unique. But in case of union or that uniqueness will not be considered, and instead of unique student name, all the records or all the student name from class A will append with all the student names from class B. And also, if we are taking performance as a constraint, it is not recommended to use union and it is recommended to use union all, because in case of union all, the SQL engine does not have to compare the result and find duplicates. So union all will perform better compared to union. So that is the difference between union and union or. Now next question is, what is the order of execution in SQL code? This is a very important question because getting to know the order of execution of SQL code will help us write better SQL code compared to the other way around. So the order in which SQL will execute is the from clause will execute first, then where clause will happen, then group by, followed by having clause, then select clause, order by, and finally top. So this is the basic order of execution in SQL code. And I have an example to explain this. So here what we are trying to achieve is we are getting the average salary for each department where salary should be greater than 50,000 and employee count per department should be greater than 3. So here what happens is, so from employee table that is happening first. We are taking all the records from employee table and then a where condition is applied. So the employees or the records for which salary is greater than 50,000 will only be taken to the next part of query. And then a group by clause is happening based on the department name, because there is an aggregate function here in the select clause. Also we have a having clause. So we have a group by based on department name. That is the next thing in the order of execution. Then coming down, we have a having clause based on which the aggregated data is filtered. That is the department name for which employee count is greater than 3 only will considered in our output. So having count of employee ID greater than 3, and now the select clause will happen. That is select department name average of salary, and we are giving a name as average salary. So that part will complete, and now we have to order the result. That is order by average salary. So now we have completed this select clause, or select part is completed, so that we can use this alias name in the order by query. So as you can see, I don't have to write average salary here. I can directly use the average underscore salary name, because before order by clause, select clause has completed running. So now we are ordering the result based on average salary in descending order. And now if we want only the top one department based on average salary, what we can do is, after not here, sorry, here in the select clause, we can write a top one department name average salary as average salary. Now this query will return only the department with the maximum average salary for the following conditions specified in the query. So this is the order of execution for SQL code. Now moving on to next question. How many joins are required to join 8 tables? So I have seen people asking these questions very commonly. The basic or the simple equation that can be used to answer this question is n minus 1, where n is the number of tables. So here we have 8 tables or 8 input tables. So the answer will be 8 minus 1, that is 7. So 7 joins should be used to join 8 tables. But initially when we hear this question, our first answer might be 4, because there are 8 tables and we are joining every table with every other table. So sometimes the initial answer can be 4, but just try writing a simple example like this one. So consider that we have 8 tables, and now we want to join these 8 tables. So what happens is, we join table 1 with table 2, and we write the on clause where we specify the join condition. Similarly for table 2 and table 3, we are writing another join condition and next join condition. Then after table 4, again one join condition, and that will continue after 5, 6, and finally after 7 also. Now simply count the number of joins we have used, that is 1, 2, 3, 4, 5, 6, 7. So here we have 8 tables, so we have used 7 joins. So in order to join 8 tables, we will have to use 7 joins. Similarly, consider that we have 100 tables. How many joins should be used to join the join all those 100 tables? The answer should be 100 minus 1, that is 99. Moving on to next question. So what is the difference between a candidate key, a primary key, and a unique key? So all the three terms, that is candidate key, primary key, and unique key, are related concepts but with different roles. So these are very similar but has got only minor differences. The candidate key are set of columns that could serve as the primary key. Primary key is the chosen candidate key for unique identification, and unique key enforce uniqueness but may not be primary identifier for the record and can also have null values. So there can be multiple candidate key for a table. From that candidate keys, we will take only one key as the primary key, and there can be columns where the unique constraint is also specified. So that column will only have unique values. But the thing is, since the column, since for the column only unique constraint is specified, it can also have null values. So we cannot take that column as a primary key column or a candidate key. So that is the basic difference between candidate key, primary key, and unique key. Moving down, I have mentioned three examples for the same. Here in the first example, example of employee ID and social security number acting as the candidate key. And now when we come down, you can see that I have created a table called as employees table. And here an employee can have a unique employee ID and it cannot be null. A employee will definitely have an employee ID. Also, he will definitely have a social security number, and it can also not be null. So these are two candidate keys which can act as primary key. So the choice of primary key depends upon the database developer or depending upon the requirement of project. So any among employee ID or social security number can act as the primary key for this table. And coming down, we have the employee ID chosen as the primary key for the table. So out of social security number and employee ID, I have taken employee ID as the primary key column for the employees table. And coming down, here is another column which is added, that is the email column, on which the unique concern is specified. So here the email can sometimes have null values. It can be because of some issues with the database. So we cannot consider email as a primary key or a candidate key. Instead, we will specify unique constraint on the email column. So that is the basic difference between candidate key, primary key, and unique key. Coming down, the next question is explain the purpose of SQL case statement with example. Conditional expression that allows you to perform conditional logic within a query. So that is the simple explanation of case statement. So case statement helps us perform conditional logics within a query. So the basic syntax for case statement is this is the basic syntax. So we'll start with a case, and when we will specify the condition, and then based upon the condition the result which is required is specified here. Similarly, we will write n number of when and then conditions, and finally if any of the condition is not satisfied, using the else statement we will provide a default result, and finally we will end the case statement. So this is the basic syntax of case statement. Also, I have mentioned one example here, that is, here we are trying to identify whether an employee is a junior, mid-level, or senior level based on their years of experience. So here we are taking employee ID, first name, last name, and years of experience from the employee table directly. And also one more column is added, that is the experience category. And here we are using the case statement, that is case when years of experience less than 3, then that employee is considered as junior. Or when years of experience is greater than or equal to 3 and years of experience less than or equal to 7, then that employee is considered as mid-level employee. And when years of experience is greater than 7, that employee is considered as a senior employee. And if something is not specified, we will provide the text as not specified, that is default category if year of experience is null or unexpected value. That is the use of case statement in a query. Moving on to our next question. The next question is, what is a subquery and where can subquery be used? A subquery is also called as nested query or inner query. So the question can also be like, what is a nested query or inner query? So don't get confused. A subquery, nested query, or an inner query is the same thing. A query that is embedded within another query is called a subquery. So the query in which it is embedded is called the outer query, enclosed inside parenthesis, and can be used in various parts of SQL statement. So subquery will be enclosed in parenthesis, and it can be used along with select statement, from clause, where clause, and having clause. And here we have two examples in which we are using subquery in where clause and subquery in having clause. So in the first example, we are trying to retrieve employees belonging to engineering department. So in our query, I'm using two tables. The first table is employees table and the second table is departments table. So in our employee table, we don't have a column called as department name. So what we are trying to achieve here is we are trying to get the department ID from the departments table and trying to equate it with the department ID column from the employees table. So we are selecting all the records from employee table where department ID equal to, now we are using a subquery. And inside the parenthesis, we are specifying select department ID from departments where department name equal to engineering. So this query will fetch all the department ID corresponding to engineering department name, and only the records specified with the with those department IDs will be provided in our final output. And coming down, we have a having clause in which we are using subquery. So here we are trying to find employees whose average salary is greater than a certain threshold. Here the threshold is the total average. So we are selecting employee ID, first name, last name, and then we are using an aggregate function which is the average salary, and giving an alias name as average salary from employees table, and group by employee ID, first name, last name, all the three column names which we are using in our input. And this is taken from employee table, and after the group by clause we are having a having clause. So here the filtering based on having clause is happening, having average salary greater than the total average. So inside parenthesis we are writing the subquery, this is the subquery. So we are taking select average from employees, sorry, average salary from employees. So this query will return the overall average salary from employees table, and using a subquery in from clause is relatively simple compared to using the subquery in having clause or where clause. Now the next question is, what is a stored procedure and when would you use one? A stored procedure is a pre-compiled collection of one or more SQL statement, and it is created and stored in a database management system and can be executed by applications or stored procedures. So we may use stored procedure to trigger different actions in our database. So we can connect these stored procedures with applications like Tableau, Power BI, or other BI applications, or even mobile apps. We can connect these stored procedures. So based on some actions which happen on those applications, some actions will be triggered in our database based on the definition of our stored procedures. So that is one use of stored procedure. And we have an example of stored procedure here created. So what I'm trying to achieve here is trying to get all the records of employee from the employee table where employee id is specified within the stored procedure. That is, whenever we are trying to execute the stored procedure, I'm providing the employee id as a separate input. So this is the basic syntax. So create stored procedure, that is create procedure, and this is the procedure name, that is get employee id by get employee by id, and this is the input parameter, that is at employee id, which is an integer. And now we are beginning the stored procedure definition, that is begin select star from employees where employee id equal to at employee id. So whatever we are providing as an input to the input parameter at employee id will be provided in this where clause, and we will get an output based on that. So whenever we are trying to execute this stored procedure, that is exec execute get employees by id at employee id equal to 101, we will get an output where the records for employee id 101 will be fetched and returned. And these are some other cases where we use stored procedure, that is in order to run complex queries, and if there are like multiple custom aggregations and it is hard to execute all this in the backend of some BI tool, we may use some kind of stored procedures. And in order to run scheduled jobs and data pipelines, and in order to run data updates in our database, we may use stored procedures. And moving on to our final question, that is, what is the purpose of SQL check constraint? Check constraint is used to specify a condition that must be true for each row in a table. Ensures that the value in a specified column or combination of columns meet a certain condition, and any attempt to insert or update data that violate this condition will result in an error. So the common purpose or the purpose of SQL check constraint is to maintain the data integrity within the database. And here is an example of using check constraint on a single column and check constraint on multiple column. So for this persons table, we are providing the check constraint for age column. So here we are checking the age is greater than or equal to 18. So that constraint is specified on age column. So the input should only contain age that is greater than or equal to 18. And if we are providing an input for the age column which is less than 18, it will throw us an error. So that is how we apply check constraint on a single column. And coming down, here is an example of check constraint on multiple column. So here we have different columns called as id, last name, first name, age, and city. And on this age column and city column, we have a constraint created called as check underscore person, and we are checking if the age is greater than or equal to 18 and city equal to Texas. So whenever we are trying to insert record into this person's table, age should be greater than or equal to 18 and city should only have one value, that is Texas. Other than that, it will give us an error. So this is how we can specify constraint on multiple columns. We can add more columns if required, but here we are specifying it on two columns, which are age and city column. And if you like this video, subscribe our channel for more. Thank you.